Hi everyone. I had promised that I would make a video after looking at your assignments from last week, the ones turned in on Moodle, as well as the Chapter 1 homework on Mastering A&P. And I found a few misconceptions, I guess you would say, misunderstandings. So I definitely want to go over the negative feedback loop and the components of the negative feedback loop. And then I want to go over directional terms and body regions, or abdominal regions, the epigastric and hypogastric and all of that, the 9 different abdominal regions. So let's start with the negative feedback loop, and let's use glucose. And the reason I say glucose for the condition, blood glucose levels, is because well, one, I understand it really well because my daughter is a type 1 diabetic. And there are a lot of diabetics in this country, but also because there are some questions on the homework assignment that may end up on your exam 1 that are about the glucose negative feedback loop. So I want to make sure you understand all the components. So if we start out with glucose, I know that's hard to see. That's a little darker. If we start out with glucose as our condition, so blood glucose levels as our condition. So what happens if, for some reason, blood glucose levels rise? And that happens when we eat. It can happen because of stress. A lot of you listed some of the reasons why the condition could go up, which is great. But all you really need to do is say, increase glucose. This is your stimulus. Increased glucose is your stimulus. Now, the cells in your body that detect increased glucose are cells found within your pancreas. They're sensory receptor cells found within your pancreas that can detect when your glucose rises and when it falls. So what you would call the receptor would be cells in your pancreas. You didn't have to name the exact cells, but we can put that this information is detected by receptor cells in the pancreas. And so there's your receptor, because remember, you had to label all the components of your feedback loop. You had to label the condition, the stimulus, the receptor, the control center, the effector, and the response. So the receptor cells in the pancreas, when they detect high glucose, what they do is release insulin. And that doesn't make the pancreas the effector, it makes it the control center. Insulin is a hormone, it's a chemical messenger. That was one of your questions, and several of you missed it. That was one of your homework questions. So the control center is actually the pancreas. And it does release a chemical messenger, but that is not the response. The chemical messenger is, it's a chemical called hormone that is released by the endocrine system. Your 2 control center body systems are the endocrine system and the nervous system. Well, in this case, the pancreas is an endocrine gland, and it's going to release insulin as a chemical messenger to tell the effector, which is your liver, what to do. Now, I did not tell you that you had to label the chemical messengers or that you had to explain how the control center got its message to the effector, but I'm going to label it here because it's one of your questions on your homework. So insulin is a chemical messenger. It's actually a hormone. And that insulin is going to travel to the cells of your liver. Your liver does a lot of different things. One of the things it does is help maintain blood glucose levels. So the liver is our effector. And the response is going to be that the liver is going to remove glucose from your blood, store it as glycogen, and then your blood glucose levels will drop. So the response is decrease glucose. Now, there's also the bottom half of this negative feedback loop, which would be what happens when your blood glucose drops. The chemical messenger in that case would be glucagon. Glucagon will help raise your blood glucose levels.